Today we're going to look at hypothesis testing traditional approach for a one population variance. And in this example, we have a bottling company claims that the variance of the amount of sports drink in a 12-ounce bottle is no more than 0.4 ounces squared. A random sample of 31 bottles has a variance of 0.75 ounces squared. At a alpha is equal to 0.01 level of significance, is there enough evidence to reject the company's claim? Let's assume that a population is normally distributed. We're going to use the traditional approach to hypothesis testing. Now here I have a setup for our steps to hypothesis testing, and it's our template that we use. The first step was we're going to identify the given values in symbolic form. So when we read the question, we want to look for the important numbers that we need and convert them into symbol format. So as we read along, I'll wait on this first sentence because that's the claim. We'll use that in step number 2. But it says a random sample of 31 bottles. So N is equal to 31. That's the sample size. And then it's saying that of those 31 bottles, their variance. So that would be a sample variance. And we label that as S squared. So S squared is equal to 0.75. And then we keep reading along, and we're going to assume an alpha level of significance of 0.01 when we do our hypothesis test. So in this second step, we're going to identify the claim, write the null and alternative hypothesis. So the claim is really this first sentence. It's claiming that the variance, that's the key word there, the variance, the population variance of all their sports drinks in 12-ounce bottles is no more than. So it would be sigma squared, that's the population variance. No more than means less than or equal to 0.40. And since there's equality in that claim, we're going to put it in the null hypothesis. So our claim doesn't always go in the null hypothesis. It just depends on if there's equality or not. But in this case, we do have the claim containing equality, so it must go in the null hypothesis. The opposite of less than or equal would be greater than. So sigma squared is greater than 0.40. So that's our claim, null and alternative hypothesis. In step number 3, we're going to calculate that test statistic. And since we're making an inference on the variance, we're going to use the formula for chi-squared. And it's equal to n minus 1 times s squared, that's the sample variance, over sigma squared, that's the population variance as well. So n we know is 31, so we're just going to fill in 31 minus 1. S squared we're already given as 0.75 in our steps 1, identifying that given information. We don't have to square it because it's already the variance given to us. We're not given the standard deviation, we're given the variance. If we were given the standard deviation, we would have to square it. And then we're given sigma squared in the claim as 0.40. And then when we simplify all that down, we're going to get 56.250 or 56.25. I'm using 3 decimal places because that's what our tables are going to use. So I'm going to be consistent with that, but you can drop the 0 at the end if you need to. And then in step number 4, we have to identify that critical region and rejection region. And remember, we have to determine if it's a 1 or 2-tailed test. We look at the alternative hypothesis. It says a greater than sign. So that means we're going to use a chi-squared, so that non-symmetric distribution. It's skewed on the right side. And then we're going to just shade in that right side. So it's a right-tailed test. And we're going to use that chi-squared with a subscript r. R just stands for the right side. We're going to put all of our level of significance of 0.01 in there. And then when we use our tables for the chi-squared, remember you're using the chi-squared table because you're using a chi-squared critical value along with the test statistic, so everything is consistent. And when I use my tables, I'm looking at chi-squared r right side. I'm looking at 0.01 in the tables for chi-squared, and I'll get 50.892 in that right side, right tail. So that means my rejection region is just what I shaded written in symbols. So I shaded on that right side. So I'm going to say chi-squared right side is greater than the 50.892. And that's our rejection region, just what we shaded in the picture there. And then in our step number 5, we're going to determine if our test statistic 56.250, so 50.892 is this center line right there, and then 56 is way over on this right side, further than 50.892. So it is falling in that rejection region, so we're going to decide to reject HO. In step number 6, we're going to make our statement, our final concluding statement. We've already decided that we're going to reject HO, so it's just repeating that. And then the next step is, since we're rejecting HO, I'm really rejecting my claim, so there is not sufficient evidence, because I basically crossed out that claim in that null hypothesis. So there is not sufficient evidence at alpha, fill in the level of significance, which was 0.01, to suggest that, and then we're going to restate that claim to suggest that the variance, I'm just recopying this statement, that the variance of the amount of sports drink in a 12-ounce bottle is no more than 0.40 ounces squared. So that the variance of the amount of sports drink in a 12-ounce bottle is no more than 0.40 ounces squared. So that is our traditional approach to hypothesis testing for a one population variance.